Hello student, good morning. I am Dr. Kumar Sinha, Professor of Chemistry. Today I am going to start part 2. Part 2, first chapter, Redox reactions. Part 1 I have finished, 100% I have finished 7 chapters. Lecture 1 to lecture 121. That was the for part 1, 11th. Now I am going to start that part 2. First chapter is Redox reaction. Then I am going to discuss now Redox reaction. And part 1, 100% I have finished. Means 7 chapters. Now I am going to start redox reaction. Listen carefully. Chemistry deals with varieties of matter and change of one kind of matter into others. Transformation of matter from one kind into another occurs through the various types of reactions. One important category of such reaction is redox reaction. Redox, R-E-D-O-X. It is you can say, 2 parts. Redox, R-E-D means reduction. O-X means oxidation. Hence, together we are telling redox reactions. A number of phenomena, both physical as well as biological, are concerned with redox reactions. These reactions find extensive use in pharmaceuticals, biological, industrial, metallurgical, and agriculture areas. The importance of these reactions is apparent from the fact that burning of different type of fuels for obtaining energy for domestic transport and other commercial purposes, electrochemical purposes, for extraction of highly reactive metals and non-metals, manufacturing of chemical compounds like caustic soda, operation of dry and wet reduction process. Of late, environmental issues like hydrogen economy, means use of liquid hydrogen as fuel, and development of ozone hole have started figuring under redox phenomena. This I have told you about the importance of redox reaction. Okay. Now I am going to discuss further, that is the classical idea of redox reactions. Okay. Classical idea of redox reaction, oxidation and reduction reaction. Originally, the term oxidation was used to describe the addition of oxygen to an element or a compound. Because of the presence of dioxygen means oxygen. Because of the presence of dioxygen in the atmosphere, many elements combine with it, and this is the principal reason why they commonly occur on the earth in the form of their oxides. In atmosphere, oxygen percentage is 20%. Then some reactions are there. The following reactions represent oxidation process according to the limited definition of oxidation. Some examples are there of where oxidation is going on. As for example, magnesium plus oxygen. Magnesium solid plus oxygen. 2 Mg plus O2, it forms 2 MgO. That is also solid. Means magnesium in oxygen, it forms oxide, magnesium oxide. 2 Mg plus O2, 2 MgO. Other example is sulfur plus O2, SO2, sulfur dioxide gas. Then this magnesium plus oxygen, it formed magnesium oxide. It in the above reactions, the elements magnesium and sulfur are oxidized, as both magnesium and sulfur in the above reactions are oxidized on account of addition of oxygen to them. Similarly, methane is oxidized owing to the addition of oxygen. Okay, means CH4 plus 2O2. CHO4 is a gas. CH4 plus 2O2, both are gas. It forms CO2 plus water. Carbon dioxide plus water. A careful examination of this reaction, methane plus 2O2, CO2 plus 2H2O. If you will see carefully, in this reaction, hydrogen has been replaced by oxygen. CH4 plus 2O2, it formed CO2 plus 2H2O. Okay. Then here a careful examination of reaction in which hydrogen has been replaced by oxygen prompted chemists to reinterpret oxidation in terms of removal of hydrogen from it, and therefore the scope of term oxidation was broadened to include the removal of hydrogen from a substance. Now see other example you can see. In this example, removal of hydrogen can also be cited as an oxidation reaction. Now you have seen in the three reaction I have given. In that three reaction, you have seen there was addition of oxygen. As for example, again I am telling you, magnesium plus oxygen, it formed magnesium oxide. Here addition of oxygen is there. Another example, S plus O2, SO2. Here also addition of oxygen is there. Third example I told, methane plus 2O2. It formed, here also methane plus 2O2, addition of oxygen is there. And it is forming carbon dioxide plus water. Now in this reaction, now I am giving further reaction where you can say removal of hydrogen is going on. 2H2S, hydrogen sulfide, H2S plus O2, it gives 2S plus twice H2O. 2H2S, hydrogen sulfide plus oxygen, it is giving 2S plus 2H2O. Here hydrogen is going to be removed. Okay. Then as knowledge of chemist grew, it was natural to extend the term oxidation for reaction like what I have discussed, which do not involve oxygen. Means now here you have seen that this two type of reaction you have seen, where oxidation was, addition of oxygen was there, and another I told you that is a removal of hydrogen. Then addition of oxygen and removal of hydrogen, that type of reaction, that type of reaction where addition of oxygen is going on or removal of hydrogen is going on is called redox reaction. It's called redox reaction. But other type is also there where there is a no addition of oxygen, no removal of hydrogen. No addition of oxygen, no removal of hydrogen. Despite that, this type of reaction is also redox reaction. Example, the oxidation of magnesium with fluorine. First example where no addition of oxygen, no removal of hydrogen, but it is also redox reaction. Then first example, I told you the oxidation of magnesium with fluorine. Second example is chlorine with sulfur, etc. occurs according to the following reaction. Means magnesium is solid, just like a ribbon. Magnesium plus fluorine is gas, F2, and it form MgF2, magnesium fluoride. Mg plus F2, MgF2. Mg plus F2, it gives magnesium fluoride, MgF2. Other example, Mg plus Cl2, MgCl2. Third example, Mg plus S, magnesium sulfide. Then these three examples I have told you, okay, where there is no addition of hydrogen, and no addition of oxygen, and no removal of hydrogen. But these are also coming under redox reaction. Incorporating this reaction, I have told you these are also oxidation reactions. Encouraged chemist to this type of reaction encouraged chemist to consider not only the removal of hydrogen as oxidant, but also the removal of electropositive element as oxidation. Removal of electropositive elements, that is also called oxidation. Keep in mind, removal of electropositive elements. Now another example also you can see, potassium ferrocyanide. Potassium ferrocyanide plus H2O2. It is forming potassium ferricyanide plus potassium hydroxide. Then now here what is going on? Here potassium ferrocyanide example is this. It's a I am telling you formula, chemical formula, K4 or FeCN whole 6. K4, that is as a cation, K4, and in bracket it is FeCN whole 6. Potassium ferrocyanide plus peroxide H2O2. It gives ferricyanide, means K3 FeCN whole 6. Means FeCN whole 6 is same in both. Only in this as a reactant it is a K4. 2K4 FeCN whole 6 aqueous solution plus peroxide aqueous solution, and it gives 2K3 FeCN whole 6 aqueous solution plus 2KOH. That is it is interpreted as oxidation. Here also this is also oxidation is going on due to the removal of electropositive element part potassium from the potassium ferrocyanide before it changed to potassium ferricyanide. Means reactant is ferrocyanide and product is ferricyanide. K3 FeCN whole 6 and ferro means K4 FeCN whole 6. Then if you will see this reaction, actually here oxidation number, now I will discuss, then you will find there is a change in oxidation number. Okay. Then this both reactions, what I have told you, that where there is no removal of hydrogen and no addition of oxygen, that is also redox reaction. and this reaction, ferrocyanide converted into ferric cyanide, okay, is interpreted as oxidation due to removal of electropositive element potassium. Potassium is going to be removed from potassium ferrocyanide before it changed to potassium ferricyanide. Then we can summarize the term oxidation. Okay, then what is the actually oxidation? Then oxidation is defined as the addition of oxygen, addition of oxygen or addition of electronegative elements to a substance, or removal of hydrogen or electropositive element from a substance is called oxidation. Here you have to just keep in mind what is the oxidation. Important things I am telling you. Oxidation is defined as the two things. First, addition of oxygen or addition of electronegative element. This is the first things. And second things, removal of hydrogen or electropositive element from a substance. From any substance, if there oxygen is going to be added or electronegative element is going to be added, then that is called oxidation. First things. Second things, just reverse way. Removal of hydrogen or removal of electropositive element from a substance is called oxidation. Okay. Then many examples I have already given you. In the beginning, reduction was considered as a removal of oxygen. Okay. In the beginning, reduction, oxidation, I told you that what is the reduction? Reverse of this definition is called reduction, reverse of this. Okay. In the beginning, reduction was considered as removal of oxygen from a compound. However, the term reduction has been broadened. However, the term reduction has been broadened these days to include removal of oxygen. Here I am talking about what is the reduction. Then reduction is what is the oxidation reverse case. Then what is that? Removal of oxygen or removal of electronegative element. Okay, there in the beginning, in the case of oxidation, there was addition of oxygen and addition of electropositive element. Here reverse case, removal of oxygen or removal of electronegative element from a substance or addition of hydrogen. There it was removal of hydrogen. Now here it is addition of hydrogen or addition of electropositive element to a substance. Okay, what I have told you in case of addition, in case of oxidation, here reverse case. There addition of oxygen, here removal of oxygen, and there addition of electronegative element, here addition of electronegative element, just reverse way. Or there it was removal of hydrogen, addition of oxygen, removal of hydrogen, that was oxidation. Here reverse case, that is the removal of oxygen and addition of hydrogen, that is the reduction. Both are reversed. Okay, and there it was addition of electronegative, here reverse ways, that is the removal of electronegative, and also there it was removal of electropositive. Here addition of electropositive. Okay, addition of electropositive element to a substance. Then here I told you what is the oxidation and reduction. Again I am briefing you because it is very, very important. First you know about the oxidation. Oxidation is defined as the addition of oxygen or electronegative element. Actually oxygen is electronegative element. Okay, oxygen is electronegative element. Then other element also may be electronegative. Then oxidation is defined as the addition of oxygen or addition of electronegative element to a substance, or in another way removal of hydrogen. You are defining in term of oxygen and hydrogen actually. Then removal of hydrogen or removal of electropositive element. Actually hydrogen is electropositive element. That's why removal of hydrogen or removal of electropositive element. Other elements are also electropositive. Okay. Then this is called oxidation, and now reverse of this means removal of oxygen, that is reduction. The removal of oxygen means removal of electronegative element from a substance, or you can tell addition of hydrogen or addition of electropositive element to a substance. That is called reduction. Means reverse of oxidation is reduction. Okay. And also here only you should know oxidation and reduction takes place together. Wherever oxidation is going on, in that reaction only reduction also takes place. Both takes place together. Only oxidation is not possible, only reduction is not possible. Both takes place together. According to the definition, I have told the following are the example of reduction process. More examples of reduction process you understand. Other example of reduction. Then mercuric oxide, HgO, Hg mercury, then HgO is mercuric oxide. Hg2 plus is mercuric oxide, HgO. Then Hg2 plus is mercuric ion, and Hg1 plus is called mercurous ion. Okay. Then here 2Hg on heating, if you will heat, it will give 2Hg, 2 mercurous ion it will give. 2Hg means Hg1 plus, Hg1 plus. Then it will give 2Hg plus 2O2. This is the reduction reaction. 2HgO on heating it gives 2Hg plus O2. Removal of oxygen, 2HgO, O was there. Now that removed, 2Hg plus O2. That's why it is a reduction reaction. Another example, 2FeCl3 plus H2 plus H2. H2 is going to be added. Then 2FeCl3 plus H2. It is giving 2FeCl2 plus 2HCl. Removal of here electropositive element, chlorine, from ferric chloride. Here chlorine is electronegative. Chlorine is electronegative and it is going to be removed. That's why this reaction is also examples of reduction. Now next example you can see CH2, that is the ethylene. CH2 double bond CH2, ethylene plus H2 plus H2. Now it is going to be added. CH2 double bond CH2. Then H2 will add and double bond will become single bond. Means now CH2 CH2 become CH3 CH3. Means ethylene becomes ethane. Here addition of H2 is there and it will form CH3 single bond CH3. Then here addition of hydrogen is there. That's why it is also called a reduction reaction. Other you can see, other example, 2HgCl2. 2HgCl2 means mercury chloride plus stannous chloride. SnCl2. Sn2 plus. SnCl2 means Sn has 2 plus. Then SnCl2 stannous. And when it will be plus 4 form, Sn4 plus. Means Sn plus 4 plus. Then that is called stannic. More charge means ik. Less charge means us. Okay, OUS. Then here 2Hg plus SnCl2. It forms Hg2Cl2 means mercurous chloride. Mercurous Hg2Cl2 means here Hg is in plus 1. Hg has plus 1 oxidation number. Then HgCl2 plus SnCl4. Two products it is giving. Hg plus SnCl2, it gives Hg2Cl2 plus SnCl4. That is the stannic chloride. Here addition of mercury. Here addition of mercury to mercuric chloride. Okay. Here addition of mercury to mercuric chloride. Okay. Here it is converting HgCl2 is converting to Hg2Cl2 and SnCl2 is converting to SnCl4. This is the also example of, you can say, simultaneous oxidation of stannous chloride to stannic chloride. Two things are going on in this reaction. First, that is the simultaneous oxidation. Oxidation of what? Stannous chloride to stannic chloride means Sn plus plus converted to Sn4 plus. That is the oxidation. Okay. Similarly, HgCl2, Hg was 2 plus, now became Hg1 plus. Okay. Then this is the reduction. Here Hg2 plus became Hg1 plus. Then here this is the charge decreased, plus 2 became plus 1. Okay, means gain of electron. Gain of electron is reduction and loss of electron is oxidation. Always keep in mind. That's why here SnCl2, Sn was plus 2, now it became SnCl4 means Sn has 4 plus. Then loss of electron, that is called oxidation, and gain of electron, loss of electron is oxidation. Example, here I told you Sn2 plus, now it became Sn4 plus. Okay, removal of electron, loss of electron. But here now you can see HgCl2. There HgCl2 means Hg was 2 plus. Now it becoming Hg1 plus means 1 electron it got. Gain of 1 electron. 2 plus became 1 plus. Electron is negative charge, don't forget. Then 1 electron it got, then 2 plus became now 1 plus. Then gain of electron. Gain of electron is called reduction. Then here also this is the new concept I told you of oxidation and reduction, where you can't see there is no sign of hydrogen, no oxygen, but redox reaction is going on. Here you have seen HgCl2 plus SnCl4, no oxygen, no hydrogen, but oxidation reduction is going on. Okay. Then here you have seen that simultaneous oxidation of stannous chloride to stannic chloride is also occurring because of addition of electronegative element chlorine to it. Okay, addition is going on. Electronegative element chlorine is going to be added. That's why here it is called reduction reaction. Simultaneous oxidation of stannous chloride to stannic chloride is also occurring because of the addition of electronegative element. It was soon also realized after these things, electronegative addition of electronegative element or removal of electronegative element, addition of electropositive element, removal of electropositive element. After this, also chemists just realized something new. It was soon realized that oxidation and reduction always occur simultaneously. I have told you. Hence the word redox was coined. Why redox is written? This was the main reason, because reduction and oxidation takes place together. That's why the term redox is used. Okay. Now just here one problem is there that I want to solve it, and in examination from this chapter also many question is asked in the form of problem. Then what is this problem? Then try to understand. I am reading the problem. In the reaction given below, identify the species undergoing oxidation and reduction. Means they have given two reaction they have given, and they are asking you tell me that which species is going undergoing oxidation and reduction, because for the reaction two substances required. Then here first question is that but they have given molecule like this H2S and chlorine. Two species they have given. First reaction H2S plus Cl2, both are gas, and it is giving 2HCl plus sulfur, 2HCl plus S. Okay, HCl is gas and sulfur is solid. Then first you see only in this reaction which is going on, which species is going oxidation and which species is going reduction. First you see only this. Then reaction is H2S plus Cl2 and product is 2HCl plus solid sulfur. Then which species is going just going on oxidation and reduction. Then here you can see very easy that H2X is oxidized. How you can understand it is oxidized? H2S is oxidized because a more electronegative element, chlorine, is added. Chlorine is going to be added. Electronegative element chlorine is there. Electronegative means which require electron, which can attract the electron, like oxygen. Chlorine is also chlorine, fluorine, bromine, iodine. All are electronegative element. Then this chlorine is going to be added. Okay. Then H2S is oxidized because a more electronegative element, chlorine, is added to hydrogen. Okay, to hydrogen for a more electropositive element. Hydrogen is a more positive, electropositive element. Okay. And another way also you can tell hydrogen is going to be removed. H2S was there. Now H2S removed and it formed HCl plus S. Then H2S is oxidized. H2S is oxidized because a more electronegative element, chlorine, is added to hydrogen or more electropositive element. Hydrogen has been removed from sulfur. Okay, H2S was there. Now from H2S, a hydrogen gone. Then hydrogen gone. Then loss of hydrogen is oxidation. Loss of hydrogen is oxidation. Correct? Then here hydrogen has been removed from silicon. Chlorine is reduced. Chlorine is reduced due to addition of hydrogen. Okay, chlorine is reduced due to addition of hydrogen. Correct? And H2S is oxidized because a more electronegative element, chlorine, is added. Okay, then this is this explanation. H2S plus chlorine. Then here this was question was identify the species undergoing oxidation and reduction. Then H2S is oxidized because a more electronegative element, chlorine, is added. Chlorine, then according to the definition, addition of oxygen or addition of electronegative element, that is called oxidation. Then H2S is oxidized and chlorine is reduced. Okay, due to why reduced? Then chlorine is reduced due to addition of hydrogen. Addition of hydrogen, that is a reduction. Now second is there. Second question was there. Only in that two part was there. Second part, 3Fe3O4. 3Fe3O4, ferric oxide. Here also the ferrous will be in two form. Fe2 plus, that is ferrous. Fe3 plus, that is the ferric. More positive charge is called Ik, ferric. Okay, and less positive charge is called As. Then here Fe3O4, this is actually ferric oxide. Then 3Fe3O4 plus 8 aluminum, it is giving 9Fe plus 4Al2O3. This is also important reaction. Okay. Then this second part, that is you have to find out, identify, that is the 3Fe3O4. This is a solid, plus aluminum, also it is solid. Both reacted and it form 9Fe solid plus 4Al2O3 solid. All are solid. This is a rare. This reaction is rare. All are in solid. Generally, reaction will take place in liquid state. 99% cases. This is the rare example you should keep in mind. Okay, Fe3O4 solid plus aluminum, 8 aluminum, that is a solid. Balanced equation is 3Fe3O4 plus 8 aluminum and it is giving 9 ferrous plus 4 aluminum oxide. All are solid. Then here you can see what is happening. Then here aluminum is oxidized. Why aluminum is oxidized? Because it is these things losing the oxygen. Fe3O4, now it is converting to Fe, loss of oxygen. Then loss of oxygen, that is the what? Aluminum is oxidized. Why aluminum is going to be oxidized? Because oxygen is added to it. Okay, aluminum is becoming now aluminum oxide, Al2O3. That's why This is the oxidation is going on. Aluminum converted to aluminum oxide, addition of oxygen. That is the aluminum is oxidized. And here ferric oxide, what will happen ferric oxide? Here loss of oxygen is going on. Fe, 3O4 is converting to Fe. Then loss of oxygen, that is the reduction. That is the reduction. Then here Fe3O4 is reduced because oxygen has been removed from it. Now third part of this question. 2Na means sodium. 2 sodium plus H2. It forms a sodium hydride, NaH. This is again, this type of reactions again not many, less can say reactions are like this, hydride form. Generally hydrogen will react, then it will lose the electron. Generally hydrogen will lose the electron. Only one electron it has, that generally it will lose and it will form Na plus. But here in this case it is taking one electron because it has capacity to have two electrons. Then now one electron, it now in this here taking one electron. It can do both way. It can lose that single electron also and it can take the one electron also because its capacity is 2. Okay. Then here it is taking one electron. Okay. That's why H minus. Now H minus hydride ion. Generally it will be H plus ion, proton, but now here is a hydride ion. Then third part of the question is that 2Na solid plus H2 gas, it will give 2NH solid, sodium hydride. Then here what is going on? Sodium is converting into hydride, addition of H. Addition of H means what? Reduction. Then sodium reduced. Sodium reduced because the sodium has this hydrogen has attached with sodium. Okay. And hydrogen for what? That also this. So this when sodium reduced and H is added. Here sodium has, in sodium hydrogen is added. That's why sodium reduced. With the careful application of the concept of electronegativity, only we may we can infer, when we can conclude that sodium is oxidized. Sodium is oxidized and hydrogen is reduced. How? Because sodium is losing electron. Sodium has one electron, Na plus. Na, sodium 11 electrons are there. Then last electron is sodium has one electron in outermost orbit. That is going to be lose. Okay. It will form Na plus, loss of electron. Loss of electron is called oxidation. And who is taking this electron? Then hydrogen is taking this electron. That's why here you can say that here we can tell that sodium is oxidized. Sodium is oxidized and hydrogen is reduced. This is another concept. Only by seeing this hydrogen oxygen only, that is not the only basis to tell oxidation and reduction. This is also electronic concept is there. Okay, that will be always correct. Then here this sodium is oxidized. Sodium is oxidized and hydrogen is reduced because hydrogen has taken the electron. Okay, because product is reactants are 2, product is only 1, sodium hydride. Hence hydrogen you can't compare. Na you have compared. Na you can compare, okay, that NaH is coming. NaH is coming. Then what about the H2? Only one product is there. Then how will you compare? Then here new concept is coming, that is for loss of electron and gain of electron. That is the main concept. Loss of electron is oxidation, gain of electron is reduction. Then in NaH product is formed, then here Na is losing the electron. I have told you oxidation reduction takes place together. Then in this reaction what is happening? Then sodium is going to be oxidized, NaH, product is NaH. Sodium is going to be oxidized and hydrogen is going to be reduced because hydrogen is taking the electron. Okay. Then here if you will see like addition of oxygen and removal of hydrogen, that is the oxidation, then here you will see Na 2Na plus 2H2, it is giving 2NaH. Then addition of hydrogen is there. Then that way reduction is there. Addition of hydrogen is reduction according to the definition. But what about these things? Hydrogen, sodium, okay. So with sodium hydrogen attached, then this is reduction. Then oxidation. Then reverse case you can tell Na attached to the hydrogen, Na attached to the hydrogen, then oxidation. Oxidation in that way also you can tell like that. Na attached to hydrogen or hydrogen attached to sodium. Okay? You will see that is the same things. Hydrogen attached to sodium. Then hydrogen attached, it means these things, hydrogen attached means reduction. And sodium electropositive, it is attached to hydrogen. Correct? Then both are going on, both are giving the same product, Na plus 2Na plus H2, 2NH. Then in this here sodium is oxidized, and hydrogen is reduced. Okay. Then electronic concept is very clearly you can understand, and that is very, very important also. Okay. Then according to the product you can tell NaH, very clear, Na is losing the electron, which means oxidized, and hydrogen is taking the electron, that is it is reduced. Okay. You can understand by definition also both way, because hydrogen gain of hydrogen is there. Okay, gain of hydrogen is reduction and loss of hydrogen is oxidation. Then where oxidation is going on, there reduction will go. Then here which one is going on in the case of sodium hydrogen, which one is going on these things oxidized or reduced? Then by seeing the product you can tell. Now sodium is oxidized, hydrogen is reduced. Now another you can say this concept only in details with some examples I want to tell. Okay, that is a redox reaction in terms of electron transfer reaction. Electron transfer reaction, what I told already, loss of electron, gain of electron. In that term also you can know. Then example I am telling you, by example which easily you can understand. 2Na plus Cl2, 2NaCl. 2Na plus Cl2, 2NaCl. Then here just what you will do, that for each atom in a reaction, whatever atom is involved, for each atom just you write the you can say, just to see which one is losing the electron and which one is gaining the electron. Which is losing the electron, there you write positive charge. If one electron it is losing, write one positive charge. If two electron, any atom is losing two electron, then there on his head you write two positive charge. And which one is gaining electron, on his head you write negative charge. If one electron taking, gaining, then one negative. Two negative, if two electrons gaining means two negative. Three means three negative. On their head you can write. Okay, just like you can say sodium, it will lose generally one electron, then one positive charge. On the head you can write. Calcium, they can lose two electron, then two positive charge. Magnesium can lose two electron, then two positive charge. Aluminium can lose three electron, then three positive charge. Like that way, on head you can write in the balanced equation. First you write balanced equation, after that this you write. Reactant side also, product side also you write. Okay, then here I am telling you as example, Na plus Cl2. Na is solid, Cl2 is gas. Then balanced equation if you write, then 2Na plus Cl2, it will give 2NaCl, solid. Okay, then here you can see, atom by you can see 2Na, there was no charge. When there is no charge, neutral, it means 0 you write. For the metal, again here you understand, for the metal it is written 0 charge, 0. Or for the gas also, like H2, Cl2, N2, O2, you write 0, 0 charge. Okay, on head you write 0 charge for metal or for gases. Okay, 0 charge. Then here what you will write here, that now 2Na plus Cl2, 2NaCl, you can write 2NaCl. Then here Na plus Cl minus, Na plus Cl minus, because Na is converting into Na plus. Na, don't see, only write the balanced equation, but you see atom wise, who one is losing or gaining the electron. Then here you will see Na is converting to Na plus, means it lost one electron. Here coefficient has no meaning, only balanced equation you have to write. But atom wise you see whether it is gaining or losing. Then Na, now it is becoming Na plus, and Cl2, because Na was 0 and Cl2 is also 0, then Na convert NaCl, the Na has one positive and Cl has one negative, means balanced equation is there. 2Na plus Cl2, it is giving 2NaCl. Then here 2Na plus you are getting, and 2Cl also, 2Na plus and 2Cl, means you can write 2NaCl, Na plus Cl minus, solid. Then here by arrow sign also you can write upside, Na, upside you can write, from there one arrow you can put upside and it should come to the Na, then it is showing Na is converting to Na plus, and Na was 0, having 0 oxidation state, now it has plus 1, 1 plus. Similarly, chlorine down you can write an arrow from chlorine to chloride ion, from chlorine to chloride ion, means chlorine was having 0, now it is becoming Cl minus, means chlorine has got 1 electron. Then sodium has lost 1 electron and chlorine has got 1 electron. Then 2 sodium was there, hence means together 2 each Na lost 1 electron, means 2 electron, 2 Na lost 2 electron, and 2 chloride ion, because it formed 2 NaCl, then 2 chloride ion got 2 electron. Each chloride ion 1 electron. Then like that way, loss of one side there is a loss of electron, then other side it is a gain of electron, and loss of electron is equal to gain of electron. Loss of 2 electrons, sodium has lost total 2 sodium was there, each sodium 1 electron lost, and 2 chloride ion formed, each got 1. Then 2 loss of electron and 2 gain of electron. Okay. Now you can say other. Then this loss of electron, I told you, oxidation, and gain of electron is called reduction. Now another example you can see, 2Na plus O2. 2Na plus O2, it will give you 2NaO or Na2O, you can say sodium oxide. Sodium oxide, Na, 2Na plus O2. Then you can write both way, Na2O you can write, or 2NaO also you can write. Better to write Na2O. Then here you can see, here 2Na was 0 in the beginning. Now it has given 2 sodium ion. Each was having 1 positive. Na plus, and oxygen got 2 minus. 2 minus means electron lost by the 2 sodium. Electron lost by 2 sodium and oxygen got these 2 electron. That's why you are writing Na and 1 O, Na2O. Then Na plus whole to O. Oxygen has 2 minus. Then here you can see sodium has lost the 2 electron and oxygen means oxygen got 2 electron. O2 got 2 electron. That's why we are writing here oxygen 2 minus. Then here Na2O. Then here also loss of 2 electron and oxygen got 2 electron. Then Na2O. Okay. Then there is also loss of electron. Sodium has lost 2 electron, means oxidation took place. Sodium oxidized and oxygen reduced. Oxygen gas 2 electron. In the first case, sodium oxidized and chlorine reduced. Okay. Third example you can see, that is the sodium plus sulfur, 2Na plus S. Then Na2S. It formed Na2S. Then here again sodium has lost 2 electron, 2Na plus S. In the beginning Na was 0, S was 0. But now in the product side Na plus and sulfur 2 minus. Then sodium has by this arrow also you can show that sodium now it is converting into Na plus. Okay, and down arrow you can show that sulfur is converted into S2 minus. Then loss of 2 electron and here gain of 2 electron. Sulfur has got 2 electrons and sodium oxidized and sulfur reduced. Okay. For convenience, such of the above process can be considered as 2 separate steps, one involving the loss of electron and the other the gain of electrons. As for example, we may further elaborate one of these reactions. 2Na is there. 2Na sign of arrow you can give. Separate reaction you are writing. 2Na arrow sign you write and you write 2Na plus. 2Na plus. Plus 2 electron because it is losing the 2 electron. Then 2Na is giving 2Na plus 2 electron. This is called half cell reaction. Half reaction only you can tell half reaction. Actually in cell also reaction takes place. Okay. Then here 2Na is converting now, it is giving 2Na plus 2 electron. Okay, half reaction, that is called oxidation. And second reaction Cl2 chlorine gas, it is taking 2 electron and it is giving 2Cl minus. 2Cl minus means chloride ion. then Cl2 plus 2 electron, then this is the reduction, gain of electron is reduction. Then Cl2 was neutral, but it is taking 2 electron plus 2 electron, then and it is giving 2Cl minus. Okay, then this process Cl2 plus 2E, sign of arrow, it is giving 2Cl minus. This is another half reaction. Then if both reaction you will add, oxidation reaction and this reduction reaction, then you will get net reaction, NET, net reaction. Then both in net reaction both electron will be cancelled out, because in the oxidation it is losing electron, Na is giving 2Na plus 2 electron, and chlorine is taking 2 electron. Okay, then loss of 2 electron or gain of 2 electron, both electron will be cancelled out. Then net reaction you will get if you add both half reaction, that is oxidation, and another half reaction, reduction. Then oxidation and reduction, if both you will add, then net reaction you will get 2Na plus Cl2, that is 2Na plus Cl, or directly you can positive 2Na plus Cl minus, or without sign also you can write 2NaCl. But when you are want to show loss of electron or gain of electron, then better you write in 2NaCl, you can write 2Na plus Cl minus, means 2 sodium 2 chloride. Okay, then this net cell reaction suggests that half reaction that involve loss of electrons are called oxidation. Okay, first step, half reaction that involve loss of electrons are called oxidation reaction. Similarly, the half reaction that involve gain of electrons are called reduction reactions. Okay, and in shortcut what we are telling, redox reaction, full reaction, net cell reaction is redox reaction. But part by part, loss of electrons are called oxidation reaction, and the another half reaction that involve gain of electron is called the reduction reaction. Now another things, here you have seen in all the reaction there is a transfer of electron, one is giving, other is taking, there is a transfer of electron. Now four, I can say, things always you keep in mind, always, because these are the easy and is common. Oxidation, what happens? Oxidation means loss of electron by any species. Reduction is gain of electrons by any species. Then oxidation, reduction, now you are knowing what is the oxidizing agent. Then oxidizing agent will be just this oxidation is going on, then who is responsible for oxidation? Who is responsible for oxidation? Means who is there to take the electron? Who is there to take the electron? Then that is called oxidizing agent. Because if another species is not there to take the electron, then how first species will lose the electron? No. Always when there is a species to take the electron, only then first species will lose, other species will take. Then for the second who is ready to take the electron, means for the oxidation process, that is called oxidizing agent. Means who is taking the electron, that is called oxidizing agent. Okay, then second species will be called oxidizing agent, because without that first one was not you can say these things, first one was not he was in a position to lose the electron. Then reverse case, what is the reducing agent? Then for the reduction, who is responsible? Then first one was responsible. First one, because second one taken electron, then who have given the electron? Then first one given the electron. Then first one is reducing agent, and second one is oxidizing agent. Correct? Because these two are responsible for each other, for each process. Okay, to gain the electron. Okay, because first species one is losing the electron, and second species is taking the electron. Then second species for the second species is oxidizing agent, because due to this only oxidation was possible, means loss of electron was possible. And reverse case, reduction, who have given the reduction? Then first one has given the reduction. Okay, then for the reduction, first one is responsible. If first one will not give the electron, then second one, how will they take the electron? Hence first one is called reducing agent. Okay, hence shortcut you can tell, acceptor of electron is oxidizing agent, acceptor of electron, and reducing agent, donor of electron is called reducing agent. Okay, then this I have told you about the, you can say, oxidation, reduction, oxidizing agent, reducing agent. Okay, and one more thing, one problem is there. You can understand only on this concept. Problem is there in examination. This type of question is asked. Okay, then now question is, justify that the reaction 2Na plus H2 2NaH is a redox change. Redox change means transfer of electron is there. You have to justify it. Then you know, since in the above reaction, means question is there, 2Na plus H2 2NaH, then you have to justify that the reaction is a redox reaction. How will you justify? Then now I am giving explanation. Since in the above reaction the compound formed is an ionic compound, NaH is ionic compound, means Na is plus, H is minus. Okay, which may also be you can write as a Na plus H minus. Sodium hydride without charge also you can write, with charge also you can write Na plus H minus. This suggests that one half reaction means Na converted to Na plus 1 electron. First part reaction, Na converted to Na plus 1 electron. Okay, one part reaction, oxidation, and second part, that is the hydrogen has taken 1 electron. Hydrogen has taken 1 electron. Then it will form H minus, Na plus 1 electron. That is the H minus, second part. Okay, if you will net reaction write, electron will be cancelled. Simple, you will get Na plus H2 is equal to 2NaH. Okay, you will get like this. Then this reaction is shown because it is forming, you can say, ionic compound Na plus H minus. Then this suggests that one half reaction in this occurs as 2Na. 2Na means it will lose 2 electron, each Na 1 electron. Then 2Na solid, it will give 2Na plus 2 electron. Okay, and same way you can say hydrogen, 2H hydrogen means H2 will take 2 electron, H2 plus 2 electron, it will form 2H minus. Okay, then this splitting of the reaction under examination into two half reaction automatically reveals that sodium is oxidized and hydrogen is reduced. Therefore, the complete reaction is a redox change. Okay, now again next class I will continue. Now I am stopping only here. Thank you.